Let's continue with Power BI. What is Microsoft Power BI? Power BI is an interactive data visualization software product developed by Microsoft with a primary focus on business intelligence. And this one is the Power BI logo. So you probably heard about Power BI a lot and see what Power BI can do. This is this is when I Google Power BI dashboard, uh, everything returned for its image. You can see the variety of visualization that you can create from a normal the tabular report to different types of pie chart, bar chart again, time series, line chart. All these are possible, and there are also like different colors, different shapes, different layouts that you can be utilizing, right? Now, with that, apparently all this comes from certain data. Where does Power BI get its data from? Power BI can get data from a variety of sources, including normal relational databases or even NoSQL databases. But mostly, the data source for Power BI is from data warehouses and or data lake houses. And this is the focus of our course too. However, the original storage format, which usually is in either relational or star schema, they may not directly fit into the analysis needs because the way star schema or relational was built was mostly focusing on storage. For the users to actually look at data and try to analyze the data, they would like to have the data in a more accessible way and a more analytical oriented way. How you would organize this data. So what the solution is? The solution is that the data can be stored into something called a cube, which is implemented based on analytical needs. Here's an example of cube. So instead of a flat or relational entity relationship diagram like flat schema, you will have the data stored and packed into each other, over each other with proper indexes. This is done so that you can slice and dice, including cut it into smaller pieces into one slice or two slices, or this way, that way. You can pivot, rotate them. You can changing the direction, and you can drill down into further details, or you can roll up into large cases. You can also apply filtering, only looking at one slide or one small cube inside. This is called the online analytical processing or OLAP. Slicing and dicing, filtering, drilling up and down, pivoting, all these are typical OLAP functions. OLAP is a software technology you use to analyze business data, and this is how you, a business user, would like to look at data instead of a flat entity relationship. So organizations usually will collect and store data from multiple data sources, combine them together, and form combine them together into the data warehouse and form a cube so that their business users can look data from multiple angles, from dimensional models, and try to perform OLAP on top of those. Further down, looking at the cube, cube is a data structure that try to break up the limitation of a relational database or even star schema by providing rapid analysis of data, by providing mechanisms, ways to look at data from a different angle, from multiple different angles. You can look at the location, different product, different time. You don't need to perform all the joins and write sequels. You just look at one dimension and doing all the slicing and dicing. Cubes can display and sum large amount of data and providing users with searchable access to the detailed data points. So this way the data can be rolled up, sliced and diced as needed to handle the variety of questions that you will be asking. In order to build the OLAP cube, you still need to get data from relational data. However, at this point, you will collecting the data, pack them together, and place proper index and labels on each data element, so that later on you can check. You will label the data with dimension. Is this in March, April, or February or January? Is this in the beverage catalog or condiment catalog, or in the confections catalog? Label the label the data cells and index them so that you can quickly access certain data points. So data eventually comes from the data warehouse, but you will do a lot of processing to make it fit into the analytical need. Power BI calls it cube semantic model, and there's a little bit marketing term involved. It was originally called cube. The industry standard calls it cube. And Microsoft originally calls it Cube in the previous version of their analytical product, which is the SSAS, the SQL Server Analytical Service. But later on, in order to break away from the industry and try to demonstrate their capability, uh, that they are able to do more than cube analysis, OLAP analysis, they claim that they call it a semantic model, and they are saying currently that it's not a cube, but for all academic purpose, this semantic model is indeed a cube for apparent reasons that we will discuss later. So before we dive into Power BI semantic model, let's talk about OLAP. OLAP, the fundamental and the functionality of OLAP is the data analysis. Depending on where the cube stores its data, there are three different OLAPs. You can store the cube data inside your system, which is called MOLAP, multi-dimensional OLAP. You will pre-compute, you will gather data from the data warehouse, pre-compute it, store it in the multi-dimensional cube format, right? This is exactly what we just talked about with labels and indexes. This will provide you with a fast query response, but it will definitely require more storage, right? Because you are basically rebuilding the data and re-indexing them with all labels. You can also do what they call a relational OLAP or ROLAP. ROLAP stores data in the traditional relational database and computes the result dynamically. So basically, you are not doing anything. You are not creating the cube beforehand. But when a request coming in to gather the data, you will run the SQL against the relational database on the fly. So this will allow you to query a larger data set because you don't need to bring in data prior and do all the pre-processing. But definitely because you are doing this all on the run, so you have a slower performance comparing to MOLAP. Then there's something called HOLAP or hybrid OLAP. It combines the benefit of MOLAP and the ROLAP. What it does is that it provides you with OLAP, a small cube with all the data indexes, but those are usually aggregated data or most frequently used data. So the cube will have the aggregated data or most frequently used data inside. If you are accessing something that's not in the cube, then you will run against the relational database. Now, the issue with this approach is that it's more complex and you may not get everything you need in one shot. So there are certain functionalities that's provided for MOLAP that you will not be able to get if you have to pull the data from the ROLAP. And the implementation of this whole lab architecture will be more complex and will cost you more money. Inside Power BI, Power BI actually provides you with all these OLAP functionalities through the usage of what is called data storage model, the data storage mode. You can set the data storage mode to define where the data will be stored. Corresponding to MOLAP is what we call import mode. Apparently, the data tells you already, the name tells already that it's imported, right? Data is imported into the Fabric Power BI system first, stored on disk, of course, with a proper label and index. But in order to use this, you must fully load it into memory so that it's faster, much faster, right? Apparently, this also requires you to have a lot of memory. Then there's the roll-up approach of direct query mode. It only stores the metadata, how to access those data that defines a model structure. When you have to get the data, it will run a query. It will issue a query against the data source and brings the data back and doing the native queries and doing all the processing, analytical processing inside Power BI. So there's also a new mode called Direct Lake mode, which is new in the Fabric mode. It was not available before because Fabric used one lake, right? So instead of running against the traditional SQL endpoint, since the one lake is completely under Microsoft control, as we said before, it's completely under Microsoft control. Power BI would directly go into the one lake infrastructure and pull data there, and it can also perform certain slicing and dicing based on the one lake partition. So this will bring back data whenever requested. Instead of saving it in the Power BI system. So that's a roll-up, but then it fetches data directly from the Delta Lake, the Delta files, instead of going through query interface like T-SQL. That's the difference between direct lake and direct query. Now, Power BI also allows, to a certain degree, certain fallback between modes, which is a whole lab approach, right? If import mode doesn't work, then you can run a direct lake, for example. Oops, I think So the current status of Power BI semantic model is that this Power BI semantic model is still under development. So there are certain things that's not as matured as we as users would like to have. For example, setting up this storage mode is only available in Power BI desktop, not in browser. From browser, you will not be able to set the storage mode. It will all fall back to Power BI default. Then when create the semantic model from scratch, semantic model in Fabric interface will only get data from files. If you want to use lakehouse tables, you cannot go through workspace, the workspace interface to get semantic model. You have to go through a lakehouse interface. Then each semantic model can only get data from one lakehouse, but one lakehouse can have multiple semantic models. Now, what if you need data from multiple tables from multiple lakehouses? In this case, you have to create a lakehouse for your analytic purpose and use shortcuts to map to those tables in other lakehouses. But certainly it's not as convenient as if you would be able to pull data directly from multiple lakehouses, right? But on the other hand, if you think about the architecture, this indeed is a goal of building a Go layer. You want to build a Go layer, a model, a star schema, or whatever model you would call it. Build that Go model, Go layer just for one analytical purpose. You bring data from different places. Build a Go layer for that analytical purpose, right? So in a sense, this fits into the medallion architecture, but it's possible that Microsoft will change that in the future. So there are other minor usage discrepancies we're not going to be talking about. One thing to note is Microsoft is making active development on this Power BI product. So by the time when you use this Power BI semantic model, you may see something different from what we discussed today. Just don't get surprised. Okay, but we talk about all this semantic model, but what is the model? What is inside the semantic model? So basically, there are two parts. One is a definition. What table are you bringing data into this cube? Where do you get data from for this cube? That's in most cases, at least in our course, it will be a collection of relational table or star scale table and their relationships. So you will bring in a list of tables and tell Power BI, in this semantic model, these are the tables that we'll be utilizing, and these are their relationships. With this definition, that's good enough to start a rollup, right? The relational OLAP. But it's also possible that you want to bring in data. So that data is also defined. Either you define how to fetch the data, which is the rollup approach, or you define how to store those data from these tables. You will bring in the data immediately, import it, and save it into Power BI system, and use that uh, in memory whenever you request it. So either way, it's a MOLAP or LOLAP. Power BI semantic model contains these two parts. So in order to create a semantic model, you will create a semantic model for Lakehouse by introducing tables. As we said, currently, you can only create a semantic model based on Lakehouse. If you want to utilizing Lakehouse tables, you will introduce those tables into a semantic model, and you will set up relationships among these tables. And then you can save this and use this semantic model in Power BI.